And Erik Swahn is an architect and programmer. He has worked with AI applied to architecture for a number of years. He has taught courses on digital design and AI at the KTH School of Architecture, and also has an artistic practice where he works with generative methods. Welcome, Erik.
I'm an architect with an artistic practice centered around generative methods. So not just AI in particular, but AI has been something that's interested me for many years, both as a tool within a design practice, but also as something that has an influence on us, on the way we think and work, even when we're not using those tools. And broadly speaking, I would say there's a divide in how we relate to and what we expect from AI tools, and what we see as the point of using AI. So I would say either in broad terms, we want to do what humans do, only perhaps faster and better, more scalable, and I think probably most of all, cheaper. Or we wanted to do something else, or the same thing that we do, but in new ways, potentially offering other understandings or readings of the subject matter. And I've been more interested in the latter. So AI not as a way to necessarily optimize or make knowledge or labor cheaper, more efficient, but rather as a way to learn from the data in new ways and solving problems in perhaps the wrong way or in a weird way that would otherwise be out of our reach because of our way of thinking. And that's what I refer to in the title of the presentation, Qualities of the Undrawn. So these drawings, if you want to call them that, weren't drawn by a human hand. There was no thinking, no reasoning, no discussion or actual knowledge or the holistic perspective involved in the making of it, just a blind mechanical process trained on images. But I would argue that that's not only a problem or a deficiency, but it can also be a positive quality. That's an architecture without architects, to quote Rudowski. This is a generative method from 5 years ago, based on or trained on historic floor plans. And we made it using a type of machine learning model called generative adversarial networks, which is now almost obsolete. So most of the AI images we see today, often text prompted, are based on diffusion models, basically models that denoise noise. And you could argue that they produce better outputs, but perhaps these older models full of artifacts have qualities that the better models lack because of their limitations. At least in my view, I think the better the models become, in some ways, they become less interesting. But one of the most important or interesting things that came out of GANs, in my view, wasn't the specific results, but the way that they relate to knowledge or the data that they're supposed to learn from. A particular interest of mine is which metaphors from machine learning might enter our common understanding of things in the way that steam engines made us think in terms of valves and pressures. And in the GAN model, everything is ordered into so-called latent space, which is a space of all possible images from the class of images you wanted to learn from. In this case, floor plans. And the latent space of the model is a multidimensional space that contains all possible images, where each possible output has a specific coordinates. And I think it remains to be seen if latent space as a metaphor will be part of our public consciousness, but I think that the more we and others use these tools, we will be surrounded by and live within these latent spaces. And the consequence of the latent space geometry of machine learning models is that you can go from one coordinate in a space to another. This is called interpolation. Here we see a GAN model trained on building footprints. So with the spatial metaphor of latent space, you also get the metaphor of interpolation, of the possibility of moving within that space. And the underlying assumption is that everything is on a continuum of some sort. In this case, you see the interpolation as a sequences of images. And this is the same thing, only that each step of the interpolation is stacked on top of each other. So this is an illustration of how one possibility within a model can transition to another. And of course, you can have your machine learning models learn different types of images describing different things. In this case, it's elevation data from cities. So these are outputs from a GAN model of DSM data from the UK. And of course, you can use outputs as a step in some process, not just as an end product. And this is the same thing, only with the generated elevation data to extrude a plane. And within one model, you can get a description of lots of types of images within one class. So this is a model of the city of Manchester. You can combine different types of images. This is a model of London, trained on both satellite imagery and elevation data. That can be found in the training data. So relationships between vegetation and roads and buildings and so on. But it hasn't been taught anything. Its understanding doesn't come from us. This is the same type of model from Stockholm. And I think maybe for most people an AI model is something huge and monolithic, beyond the user's control, and probably from tech giants like OpenAI or Meta or Google. And in recent years, the discussion has been totally dominated by these huge generalist models like ChatGPT, where the user has little control over the underlying content. But everything I've shown so far has been made with a few years ago with small custom models trained on relatively little data on a single computer. Not everything in AI is these huge models. And we've done it here at the KTH School of Architecture too. This is from last year when I asked students to gather interior photos, and we let the model use them as training data. And then you let my training program run for a while, and gradually the model creates more and more realistic outputs. Or a pre-trained model of mostly classical paintings, and gradually the feature from the original model is transformed according to the new data. So, for example, the upper body there is transformed into the floor interior. And I recently wrote an essay on the impacts of AI on our relationship to architectural history for Arkitektur, the Swedish Review of Architecture. And I think in terms of images, I think the image of the robot on the right is kind of emblematic of how we struggle to visualize what AI looks like. I think last year most major newspapers and industry-specific magazines ran articles about the impact of AI, and a lot of the images were these sort of robots or some ethereal humanoid being surrounded with electronic blue lines and so on. But I think those images can be quite misleading and anthropomorphic, and they hint at the level of agency and individuality that just isn't there. And I think the I in AI, the sort of intelligence in itself, is sort of a very anthropomorphic way of describing something. But personally, I think that machine learning is a sort of better term for what it actually is. To me, AI looks more like this, like data for the most part. At least when we talk about generative AI, so the expert systems that Pablo talked about, or sort of reinforcement learning that Ricardo talked about, is sort of another class. But when we talk about generative AI, it's all based on data. In this case, it's the images of building footprints that were used for one of the previous animations. So the thing that's shaping the output is not primarily the algorithms, but the training data. And in popular discourse, there's a lot of talk about algorithms, how we're sort of governed by and targeted by algorithms, but I would argue that we're even more in the hands of the underlying data. And when we talk about biases in AI, it's typically the data that's the culprit and not the algorithms. Because the machine learning algorithms are sort of generalistic, they simply don't care about anything. They just want to minimize the error rate. That doesn't mean that they're objective or neutral or will deliver the truth in a way, because machine learning is a very pragmatic field. It just means that they really don't care. And in the essay, I quote Peter Eisenman from a talk about the digital and architecture. And he said, the digital starts with the primitive, that is no history, no context, and no memory. Everyone that starts with something on a computer starts with a geometric three-dimensional form that's there for no reason. It didn't come from any historical precedence. That was in 2017, but I would argue that in a digital design process that includes AI tools, that's kind of turned on its head. Suddenly, architectural history and historical precedents in the form of training data and the outputs from whatever generative model you're using becomes a type of material that can be used within architectural design. But the shaping of that material and whatever comes out of it, whatever processes you build around those tools, it all starts with the data. And that's why I think it's sort of paramount that wherever AI tools are used, they aren't just used as is, and that the knowledge of how to shape the tools isn't concentrated to the very few. Thank you.
Thank you so much, Erik. Does anyone have a question for Erik in the audience? It was very amazing work that you showed. Thank you very, very much, and also the reflections in the end that the main problem is data, and probably not how algorithms works. We should really reconsider that when there's a lot of accusations going on now to artificial intelligence, but in the end, we can also look at it as a tool, as maybe like a very powerful calculator. And that depends on us what we do with it. Don't you think?
I think Katja had a question.
Katja, thank you.
Yes, thank you so much. It's very, very interesting. I was wondering about the satellite images and the flow that we were seeing as a film animation. What is happening? Do I understand right that the training data is it just like pure satellite images with no value, or is it any? Yeah, is it just the images, like the flat images, that is the training data?
Yes, exactly.
And does it interpret the volumes?
There were a few different examples. But the ones with the sort of that were kind of extruded in elevation, that was trained on sort of images, like RGB images of satellite imagery, plus a fourth channel, so to speak, for the elevation. So it's all in one image, but
okay, so there's a mechanism to try to interpret.
So it's like 2.5D.
But I was just also curious about, so what the flow that we see in the animation, what information is that flow based on, or what is it?
Well, it isn't really based on anything, but it's sort of the because of the nature of that latent space that I talked about. So everything is not a 3D space. It's like a number of 100 dimensions, perhaps. But each possible output is like one point within that space. So you can just go from one point, producing one output, and gradually you can go to another point, and then the output will transform. So that's sort of what I meant with everything being on a continuum. It's the underlying assumption.
Yeah, really interesting. Thank you so much.
Thank you very much.